Okay, back at it again. This is chapter 14, part 2. This is a continuation of our oligopoly presentation. We are going to take a look at simultaneous games in game theory. Simultaneous games can be a little tricky to work out, so I'm going to help you through it in this presentation. In your chapter, you will also find a section on sequential games. I find most students don't have any real difficulty following the sequential games. It makes a lot more sense. Simultaneous games, on the other hand, tend to trip you up a little bit. Let's go ahead and just work through some of the basics of these games. All right, the easiest way to usually learn these simultaneous games is to just take a look at them. For starters, let's get lingo out of the way. You are going to have players. These are usually firms. In our example here, 2 airliners, British Airways and Lufthansa. Those firms are also going to be making choices about strategies. In our example, they're trying to choose between a high price for a particular air route or a low price. How they do on those strategies is going to depend on what their competitor chooses. So you have a payoff matrix. Each one of these boxes represents an intersection of 2 different strategies by the players. Those numbers will indicate how they do. In our example, the way I've set this up, Lufthansa is always your upper left corner, British Airways is always your bottom right corner. So now you've got the basics down. Players, strategies, payoffs. How does this help us actually understand what firms are going to do? Firms are always thinking about what their competitors are likely to do because they would like to choose the best choice given what a competitor is going to do. The only problem is they don't know for sure what that competitor is going to do. Game theory helps us to see the choices in front of them and also which choices likely make sense for them. So let's go ahead and do Lufthansa in green, and we'll make British Airways the red. Oops, pardon me. Okay. If Lufthansa is planning ahead and it wants to know what they should do if British Airways were to choose a high price, then they're going to go ahead and they're going to say, all right, well, if British Airways puts me in the left column, I've got to choose between 1.2 million and 1.6 million. Of course, 1.6 million is the more attractive choice. So if British Airways were to choose high, Lufthansa would be better off if they had chosen low. Now, British Airways also may choose to go with a low price. And if British Airways chooses to go with a low price, that puts Lufthansa in the right-hand column. And they're now thinking, if British Airways were to choose a low price, would I be better off choosing a high price, or would I be better off choosing a low price? Obviously, 800,000 is better than 0. So it looks as though Lufthansa is actually going to choose a low price no matter what British Airways does. We're going to refer to that as a dominant strategy. Now it turns out that British Airways is actually going to look at this in almost the exact same way since the payoff matrix is symmetrical. If Lufthansa were to choose a high price, British Airways has got to choose between a high price or a low price. They're better off with a low price. 1.6 million is bigger than 1.2 million. If Lufthansa were to go low, then of course British Airways would prefer to make $800,000 with a low price than to lose all of their customers if they had a high price. They're going to choose a low price no matter what as well. It looks as though both of them have dominant strategies. When you get 2 circled results in the same box, This is what we refer to as a Nash equilibrium. Occasionally, you'll hear it referred to as a non-cooperative equilibrium. This is basically indicating that neither player can do better by unilaterally changing their play. Given what the other player is doing, they've chosen the best outcome for themselves. This is basically a likely outcome for the entire game. One of the things that will present itself as curious here is that both of them have ended up choosing a low price when they couldn't cooperate with the other player. The reason that's curious is because, of course, you have got this scenario here, which obviously would have been better for both of them. When you get a result where individual firms acting in a profit maximizing way actually leads to them both making less money than they could have if they were cooperating, we refer to this as a prisoner's dilemma. So, is there a way out of this prisoner's dilemma? There's a couple of ways. One, you can break the law and you can cooperate. If you both have a conversation and cooperate, then you would both choose to take a high price. That'll put you in trouble with the law, though. You face possible felonies if you get caught. The other way that it can be done is with signaling. And signaling would also be illegal, but it's much more difficult to prove. So if Lufthansa and British Airways have been at this for quite some time, we would expect that British Airways and Lufthansa are operating here. If Lufthansa all of a sudden, out of the blue, decided to change from a low price to a high price, they're going to start taking a loss. Well, not a loss. They're going to make zero money. British Airways can look at this and assume a couple of things. One, Lufthansa's suddenly stupid. Or two, Lufthansa's trying to tell them something. If they don't think Lufthansa's stupid, then British Airways may read this move to a high price as an invitation for British Airways to also move to a high price. If British Airways picks up on that signal and they both raise the airline ticket price to $600 a piece, then of course they are going to end up escaping the prisoner's dilemma. And they did it without ever actually having a conversation with each other. This frustrates authorities to no end. Very, very difficult to prove collusion when there isn't a paper trail or a conversation where they're discussing how they're going to do it. Still illegal, but practically very difficult to solve for the authorities. Another common theme that will pop up here is a price leadership model or a coupon price matching scheme. If in fact one of these competitors agrees to match a low price from another competitor no matter what, that pretty much is sending a signal out to the other competitor that they should just leave their prices high. That's a way that they could also avoid this, and it looks a whole lot like competition. Interestingly enough, it's probably anti-competitive. In any event, you can escape the prisoner's dilemma if you can find a way to cooperate or, as we're discussing here, tacitly collude. All right, time for you all to try. Here's two games. I want you to figure out where the Nash equilibrium are going to be, if there is going to be a Nash equilibrium. And I'll go ahead and walk you through the solutions here in a second. So pause this presentation, try them out yourselves. When you've got answers, start it up again. Okay, let's go ahead and work through this. Pepsi's on the top left, Coke's on the bottom right. they've got to start planning around possible strategies from their competitors. Coke is going to start asking themselves, what if Pepsi chooses not to advertise? And if Pepsi chooses not to advertise, then Coke is going to be worried about this row only. Coke could either choose to not advertise or to advertise. 500 million is better than 450. Now, if Pepsi chooses to advertise, then Coke only has to worry about the bottom row. And, of course, 300 million is better than 200 million. So it turns out that Coke actually has a dominant strategy to advertise no matter what Pepsi might do. Pepsi is actually going to be in the same boat, because if Coke chooses not to advertise, then Pepsi is thinking about what would they be best off doing. The answer is advertising. And if Coke chooses to advertise, they only have to worry about this right column, and of course 300 million is better than 200 million. They're also going to want to advertise. There's another prisoner's dilemma. They're going to end up both choosing to advertise, and they're going to make less money than if they were both not advertising. Okay, let's look at this example over here on the right. And you've got two oil-producing nations, Saudi Arabia and Nigeria, and their output decisions are going to influence the world price of oil. In other words, it's an interdependent scenario. What one of them does impacts the other. So if you start thinking about this, you could have the Saudis, and they could be wondering, well, if Nigeria were to go with low output, then what would I be best off doing? Low output or high output? They're going to be better off doing low output. If Nigeria were to go with high output, the Saudis would start wondering, well, once again, low or high? Turns out that low is a dominant strategy for them. They're always going to be better off, no matter what Nigeria does, as long as they go with low output. Nigeria, on the other hand, is going to start thinking, what if Saudi goes with low output? If Saudi goes with low output, then Nigeria starts wondering, do I go low or do I go high? It turns out they're going to be able to be better off if they choose high output. If the Saudis go with high output, Nigeria once again is better off choosing high output. Turns out that Nigeria has a dominant strategy to go for high output, whereas the Saudis have a dominant strategy to go for low output. This, of course, is one of the reasons why people will say that the agreement between these nations to limit oil production has consistently failed, because some of the smaller nations in OPEC, or the oil petroleum exporting countries, all have an incentive to cheat on that agreement. Only the largest producers stand the most to gain from keeping output low. So there's a couple of solutions for you. I want you to realize that that right there is a Nash. Let's not forget that. And here's how you kind of work through them. Let me know if you have questions.